Hello children, today our new lesson is fractions lesson. Okay, under this lesson we will learn about few different types of fractions. Okay, before that I want to recall you some parts you learned that you were in grade 6. Right, see, in a fraction there are two main parts. What are those? For the bottom number we call denominator, and for the top number we call the numerator. Remember that. Okay, firstly we learnt about unit fractions. What are these unit fractions? If the numerator is every time 1, such type of fractions are called unit fractions. See, I have given you some examples. Every time the numerator is 1 only. Denominator can be anything, right? So these are unit fractions. Then we learnt about proper fractions also. What are these proper fractions? If the numerator is smaller than the denominator, such type of fractions are called proper fractions. Look, numerator is smaller than the denominator. Top number is every time smaller than the down one, right? So that is proper fraction. Next, equivalent fractions. What are these equivalent fractions? Actually, the numerators are different. They look different. Denominators also look different, but they represent us the same value. All these fractions here, all the three fractions here represent the same value, right? How can we obtain these equivalent fractions? As you remember, we can multiply both the numerator and denominator by the same value, or else divide by the same value. Remember that multiplication, no division should be done to both numerator and denominator, right? Then only we can obtain equivalent fractions. Next, in this year you learn about these two new concepts. What are those? Improper fractions and mixed numbers. Okay, improper fractions, that means upside down of these proper fractions, opposite of proper fractions. See, the numerator is now bigger than the denominator. See, numerator is bigger than the denominator. At that time we call such type of fractions what? Improper fractions. Then the last one is mixed numbers, not mixed fractions. Okay, we don't call mixed fractions, these are mixed numbers. That means there is a whole part and also fraction for the same value. See, this is the whole part, this is the fraction part. Whole part, fraction part, right? 1 1/2, 3 2/5, likewise. Now we will learn how to represent these mixed numbers using a small diagram. Okay, before that we will learn how to represent a proper fraction using a diagram. This is just a proper fraction. No, out of 3, 2 parts should be represented. So here I brought a cake. Okay, this cake is cut into 3 equal pieces. The denominator should be shown there, okay, by the total number of parts by dividing. Then to equal 3 portions I have divided and shaded 2 parts. That means 2 over 3. 2 out of 3 can be represented like that. So how can we represent a mixed number like this? 1 1/2. 1 represents the whole number. No? 1 is a whole number. That means a full cake is represented there. Half means I am taking another cake, cutting it into 2 equal parts and shading 1 part. This is 1, this is half. In the same way, 3 2/5. 3 units can be seen there. That means 3 cakes can be represented fully. Another cake I am taking here and cutting it into 5 equal pieces and shading 2 parts. These 3 represent the whole number 3, and from here we can represent 2/5. Okay, this is how we represent mixed numbers using a diagram. Next children, there is a relationship between these improper fractions and mixed numbers. We will learn how to convert an improper fraction into a mixed number and also a mixed number into an improper fraction. Now children, we will learn how to convert a mixed number into an improper fraction. Okay, see the first example. First of all, we will write the denominator as it is. Don't change the denominator, right? Then we will go to the numerator from this denominator. How? Firstly, denominator and this whole number should be multiplied. Then for that answer we obtain, we should add the numerator. That means 2 times 1 is 2, 2 plus 1 is 3. Next, same denominator should be written. Then what should we do? 5 times 1, 5. For that answer we will add 3. 5 plus 3 is 8. Next, the denominator must be 4. So here we will firstly multiply these two. 4 times 2 is 8. 8 plus 3 is 11. Next, denominator is 2. Firstly multiply, then add. 2 times 3, 6. 6 plus 1, 7. See, this is how we convert mixed numbers into improper fractions. Now children, we will learn how to convert improper fractions into mixed numbers. Okay, see the first example. This is the numerator, this is the denominator, 5 over 3, right? Any fraction represents as a division also. That means we can think that 5 is divided by 3. 5 is divided by 3. So, to convert any improper fraction into a mixed number, we will go to division method. Right, our usual division. We will divide numerator by the denominator. 3 times 1 is 3. 2 is remaining. So, this number we got up can be written as the whole number. Right? This is the quotient, right? This is the quotient and this is the remainder. Then this remainder can be kept as the numerator, but don't change the denominator, same denominator like earlier, right? Again, the next one, 17 over 10 can be considered as 17 divided by 10. Yes, 17 divided by 10. 10 times 1 is 10, 7 are remaining. Now this quotient can be taken as the whole part, same denominator. Remainder should be the numerator. Next, 17 divided by 4. 4 times 4, 16. 1 is remaining. This 4 can be placed as the whole part. Same denominator. Remainder should be the numerator. Next, 27 divided by 5. 5 times 5, 25. 2 are remaining. Next, the quotient can be kept as the whole part. Remainder should be the numerator, same denominator. This is how we convert improper fractions into mixed numbers. Now children, we are going to compare the fractions. Okay, see, in the first situation, see the speciality that you can see here, the numerators are same. If the numerators are same children, by looking at the denominator, we can compare the fractions. You think like this. Here to the class, I am bringing 3 cakes, okay. The first cake is cut into 10 equal pieces and taken 1 piece. And the second cake is cut into 3 equal pieces and taken 1. The third cake is cut into 7 equal pieces and taken 1. Which piece? Who has got the smallest piece here? This one, right? Out of 10 equal pieces, taken 1 means that piece must be the smallest one. So, here I am writing the smallest here. In ascending order, I am going to arrange. The questions can come in different ways, like arrange in descending order, ascending order, and putting greater than, less than, inequality symbols, or such type of questions can come. Right, but here in ascending order I am arranging all. Next, what should be the smallest? Out of 7, 1. Then out of 3, 1. This is the biggest fraction here. Right, you can use inequality symbol also here. Next one, in the next example also we can see the numerators are same. If the numerators are same, children, look at the denominator. Like earlier, by the biggest denominator, we get the smallest fraction. So, out of 11, 3 should be the smallest. Next, out of 8, 3 should be the smallest one. Then the biggest fraction is this. Likewise, we can compare the fractions. Next, children, now in these two examples, the numerators are same. At that time, you think practically and get the answers, okay? Compare the fractions. But here, children, we can see the denominators are same. When the denominators are same, it's little easy. It's easier than the previous one, okay? See, I am bringing here 3 cakes. All the 3 cakes are cut into 5 equal pieces. From here, taking 3 pieces out. From here, taking 1 piece out. From here, taking 4 pieces out. Which one is the smallest piece? This one, right? Out of 5, only 1 piece. No, I got. So, out of 5, 1 is the smallest one. After that, out of 5, 3 pieces. Out of all the 5 pieces, taking 4 pieces. Next, in the next example also denominators are same. So, look at the numerators and compare. Out of 10, 2 pieces means this is the smallest one. Next, out of 10, 6. Out of 10, 9. This is the biggest fraction. Right? Now, we will go to the next part. See, the numerators, are they same here? No. Denominators? No, all are different. So, at that time, children, to compare the fractions, you must make the denominators same. How do we make the denominators same? Using the equivalent fraction knowledge. See, every time we make the smaller one into the bigger ones. Okay, smaller numbers into bigger numbers only we convert. Can't we make this 3 as 6 by multiplying? Can. 3 can be multiplied by 2. Then we get the same denominator, no? Then we can make the denominator same. Is this enough? No, we should do the same thing to the numerator also. In equivalent fractions, we learned it. What is the new fraction we get? 4 over 6. Now children, this is the new fraction. It's an equivalent fraction to this one. So children, what is the smallest one? Out of 6, 4 pieces, right? This is the smallest one. Next, numerators are different. Denominators are also different. So what do? We will make the denominators same. Right. Using LCM, right? Firstly, we need to find the LCM to make the denominators same. Right. Instead of that method, I will show you a short method also to find the LCM. Take the biggest number here. Biggest denominator, 4. Right. Multiply it by firstly 2. Starting from 2, you can go 3, 4, 5, likewise you can go, okay? 4 times 2 is 8. Is 8 divisible by 4? Yes. Is 8 divisible by 3? No. That means 8 is not the LCM. Then we will multiply that bigger number by 3. After 2, 3 is coming up. 4 times 3 is 12. Is 12 divisible by 4? Yes. 12 divisible by 3? Yes. That means 12 must be the denominator. To get that denominator, 4 should be multiplied by 3, 3 should be multiplied by 4. Do the same thing to the numerators also. What are the new fractions we get? 9 over 12 and from here 8 over 12. Right, now we can compare easily. This is the biggest fraction here. See. Now children, we are going to compare the mixed numbers. Earlier we compared fractions. Now we are going to compare the mixed numbers. Look at the first example, 1/2, 3 to 5th. Right. Firstly, when we compare, look at the whole part. Look at the whole number in the mixed number. Right. Here 1, here 3. That means if by looking at the whole number, we can compare. Firstly, you think like this. For one class, a teacher is bringing 1 full cake and half of another cake, right? To the second classroom, that teacher is bringing such type of 3 full cakes and another cake is cut into 5 equal pieces and 2, right? Who got, that means to which classroom they got many cakes for this classroom, right? So, by looking at the whole number, firstly we can compare, remember that. Next, see the next example. Firstly, we look at the whole part. They are same, no? At that time, what do we need to do? If the whole part is same, we will compare the fraction part. Here 2/5, here half. Numerators are different, denominators are also different. So, at that time, we will make the denominators same and then compare. To make the denominators same, we will multiply 5 by 2, 2 by 5. Do the same thing to the numerator also. What is the new mixed number coming here? Don't do any changes for the whole part, okay? Out of 10, 4, 3, 5 tenths. What is the biggest one? Here, out of 10, 5, right? This is the bigger fraction. Next example, Look at the whole part. They are same. If they are same, go to the fraction part and compare. Numerators are different, denominators are also different. So we will make the denominators same. 6 multiplied by 5, 5 by 6. Do the same thing to the numerator also. What are the new mixed numbers that we can write? Out of 30, from here 25, from here 24. That means from 25 we get the bigger fraction. This is how we compare mixed numbers. Now children, we are going to add the fractions. Okay, after this we learn about how to add the mixed numbers, then subtracting fractions and subtracting mixed numbers. Firstly we will see this. If the denominators are same only, easily we can add or subtract the fractions or mixed numbers. Okay, here the denominators are same. No, write that same denominator. Now we will add the numerator 7, 8, 9, 10. Now children, can we stop from here? Remember that in fraction lesson, when you add or subtract fractions, finally you get an answer. No? After getting the answer, there are two things that you need to concern. What are those two things? Firstly, remember, if the answer is an improper fraction, if the answer you got is an improper fraction, you must convert it into a mixed number. Remember that it is compulsory. And the other thing is, if there is little complex, you can simplify it. That means in the simplest form, you must keep the answer. Just imagine you got the answer as 4/8. These two numbers can be divided by 2 and 4, right? By the biggest number, we will simplify. So we get half as the final answer. This is the simplest form. So using the knowledge of equivalent fractions, you can simplify as much as possible and get the simplest form. Just imagine 3/9 came as the answer here. So you can see that both the numbers are divisible by 3. So finally we got 1/3. Right? In that way you can keep the answer in the simplest form. Remember these two things. Right? Then here we will divide. To convert this improper into the mixed number, we will divide 10 by 9. Inside 10, 1 9 is there, 1 is remaining. Write the same denominator. This is the answer. Next question. Every time look at the denominator when you add or subtract the fractions. Denominators are different. To make them same, use the LCM knowledge. Okay, LCM is 24. To make these two as 24, 3 multiplied by 8, 8 multiplied by 3. Do the same thing to the numerator also. What are the two new fractions we get? Out of 24, 16 and 9. Now the denominators are same. So you can add the numerators. 25. Can we stop from here children? This is an improper fraction. So we need to convert it into a mixed number. We will divide 25 by 24. 124 is there inside this and 1 is remaining. Write the same denominator. Next question. Right. Denominators are different. LCM is 20 in your mind. You can find the LCM, or else there is a method you learned earlier. You can use it, or else the short method I taught you, right? Right. Here the LCM is 20. To make 4 as 20, multiply 4 by 5. 5 by 4. What are the two new fractions out of 20? 5 and 8. So 13/20. It is in its simplest form. Nothing to do there. Right? Next. Denominators are different. LCM is 24. Again I will recall you the short method. Out of these three numbers, select the biggest number. 8. Is 8 divisible by 3? No. 8 is divisible by these two, but it is not divisible by 3. So we will multiply by 2. Starting from 2, you need to multiply. Okay? 8 times 2 is 16. Is 16 divisible by 3? No. By these two divisible, but by 3 not divisible. So this is not the LCM. So we will multiply by the next number, that is 3, no? 24. Yes, 24 is divisible by 3, 8 and 4. This is the LCM. To make 3 as 24, 3 multiplied by 8. 8 multiplied by 3. 4 times 6. 4 times 6 is 24. Do the same thing to the numerator also. Right? What are the three new fractions? Out of 24, 49, 42. So out of 24, 91. Now we will convert this into the mixed number by dividing. Right, the answer is, then we divide 91 by 24. This is how we add the fractions. Now children, we will learn how to add the mixed numbers here. Right, when we add the mixed numbers, children, we will add the whole part separately, fraction part separately. It is the easiest method. There is another method also, by converting all the mixed numbers into improper and then addition. But here we will, this is easy, of adding whole part separately, fraction part separately. Right, 1 plus 2 is 3. Here when we add the fraction parts, denominators are same. Write the same denominator here. 1 plus 2 is 3. Nothing to be simplified also. Next, in this question, see the whole parts here. 3 is the answer. For that we will add 1/3 and 5/12. Why did I write it again? Because the denominators are different. Not like earlier. Here the denominators are not same. To make them same only, I wrote them again. Right. 3 should be multiplied by 4. Then it becomes 12, right? Do the same thing to the numerator also. We will see 3 plus 4/12 plus 5/12. Now children, place the same whole number here. Out of 12, without addition mark we can write, out of 12, 4 plus 5 is 9. Now children, we cannot stop from here because we know that 9 and 12 both are divisible by 3. They are divisible by 3. So, as the final, and remember, don't do anything to this whole number, okay? Write it as it is. When we divide 9 by 3, 3 is coming, 12 by 3, 4 is coming. This is our final answer, okay? Next, in this sum, we can see only one mixed number and one whole part is there. Write it as it is. And when we consider these two fractions, denominators are not same. So we will write them again. To make them same, what do we do? 3 multiplied by 4, 4 multiplied by 3. Do the same things to the numerators also, children. Now from here we get, just do that whole part, and from here as the new fraction we get 8/12 plus 3/12. Now 2 can be kept as it is. Same denominator. Now from these two I am writing it only once. Now we can add these two. 11. Here nothing to be simplified even. Our next example, children. See, there are two mixed numbers and also a proper fraction. See, firstly we will add the whole part of these two mixed numbers. 1 and 2 can be added firstly. 3 is coming. Then the fraction part separately we will add. So I am writing them like this. 3/5, 5/6. Now children, look at the denominators. 3, 5, 6. We know that 30 is the LCM, right? There are different ways to find the LCM. In your mind you can find the LCM, or else using any method that you have learned when you are in grade 7 you can use, or else the short method. What is that? Out of these three denominators, what is the biggest one? 6. Take it firstly. Is 6 divisible by 5? No, but 6 is divisible by these two but not by 5. So this is not the LCM. Multiply it by 2 every time, starting from 2. Start from 2. 12. Is 12 divisible by 5? No. So this is not the LCM. 6 times 3 is 18. Is 18 divisible by 5? No. 6 times 4, 24. Not divisible by 5. 6 times 5 is 30. 30 is divisible by 5 and it is divisible by 6, 3, all these denominators. So this must be the LCM. So to make all these denominators into 30, by which numbers do we need to multiply? 3 by 10, 5 by 6, 6 by 5. Do the same things to the numerators also. Now we will write the new fractions. out of 30, from here 20, 18, 25. Now children, in common I am writing 30 here and adding all these numerators. 63. Now can we stop from here? See, these two can be divided by 3, right? Simplest form I told you that. If the answer that we got as a fraction, if that answer should be kept in the simplest form, and if it is an improper fraction, convert it into a mixed number. Right here both are divisible by 3. Firstly I am dividing by 3. Okay, what will come? 3 can be placed as it is. Don't do any changes for this 3. From here we get 3 times 2, 3 times 1, from here 10. Now children, for a moment forget about this 3 and look at this fraction, 21 over 10. It's like an improper fraction, right? So consider about it separately. Divide this 21 by 10. 10 times 2 is 21 is remaining. Now children, actually here, additional to this 3, we can write this 21 over 10 as 2, 1 over 10. Think separately. Then we can add these two whole parts, 5, 1 over 10. This is the final answer. Children, we will learn how to subtract mixed numbers. Okay, this is also like adding mixed numbers. Firstly, the whole part should be simplified, then the fraction part. From 2, subtract 1. 1 is the answer. Here the denominators are same, so directly we can write the answer. From 7, subtract 5, 2. Nothing to be simplified, even this is the answer. Next one. From 6, there is no any whole part to be subtracted. So I am writing 6 as it is. Next, consider these two fractions. I am taking them separately, okay? At that time, I am putting addition mark. Don't get confused because the whole part separately, fraction part separately, no, I am taking, finally I need to combine them, no. That's why I put this addition mark. Then I am writing these two fractions, subtraction, okay? Consider the denominators, they are different. To make them same, multiply by 3. Right. Additional to this 6, what are the other two fractions coming? 3 over 9. Now children, we can see the same denominator is there. From 5, when we subtract 3, 2 is coming. This is the answer. Next one children, from 5 subtract 2, 3 is coming. Next, the next two fractions I am writing separately because the denominators are not same. What must be the LCM? 30 must be the LCM, right? So to make it as 30, multiply by 3. This should be multiplied by 2. So 3 plus 21 over 30, subtraction 4 over 30. Keep the whole number firstly. Out of 30, when we subtract this, what will come? 17. Nothing to be simplified. Next one, subtract the whole part here. From 3, subtract 1, 2. Now, we need to simplify these two also. The fraction part should be simplified. 7 by 2, 2 by 7. Right. What are the two new fractions coming? 4 over 14. Subtract 7 over 14. Right. Here, how can we subtract 7 from 4? There is a small problem here. So, what do we need to do here? Right. See, instead of 2, here I am writing only 1. We know that these two represent whole numbers, no? From 2, I am taking one whole number. That whole number I am writing as a fraction. Okay, when I am taking 1 out of these 2, another one is remaining. Then for the other one, what do I do? I am writing it as a fraction. 14 out of 14 means 1 unit, no? That 1 plus 1 is 2, no? This is how we write it. Now, this 4 over 14 is also there. What is the change I did? Instead of this 2, I wrote this whole thing. I separated, took 1 unit out of this. Just imagine 4 are there. 4 is there. Okay, I am writing 3 here and taking 1 and writing it as 14 over 14. This depends on the denominator. If the denominator is 8, 8 out of 8. If the denominator is 9, 9 out of 9, right? Now children, we can add these two, right? Or else in your mind even you can simplify here. 1 plus 14 plus 4 is 18. From 18 when we subtract 7, what will remain? 11, right? 11 out of 14. This can be written as 11 over 14. See, I added these two numerators and subtracted this because all the denominators are same here.